Alright, this is the last section of chapter 6, and so just some more complex circuit stuff. We hopefully have now been in the lab, we've looked at a basic circuit, you understand all the parts of a basic circuit and what that takes, and so now we're ready to talk about the very last part. So we know that a basic circuit consists of a battery, consists of wires, and some kind of resistor. And so a series circuit now is a basic circuit that has only one loop, meaning that if we go through, it starts, and here's an example. This is our battery. This is kind of a general diagram. That's another way to diagram battery or circuits. So this is our battery. You go through and you loop around. Don't worry about what a conductor is. You go through and you hit your resistor. In this case, you go through and you hit a couple of resistors, and then you come back around to the battery. Notice that it's all one loop. That if let me get my little pen here. Notice that if I, for example, took out this resistor here, this light bulb, that the whole thing would shut down. It's like those holiday lights where one light burns out and the whole loop of them goes out. And you got to figure out the one, light bulb that's out to fix it. Okay? That's a series circuit. Some flashlights work that way, of course, where the bulb goes out. You got to, obviously the flashlight goes out. So that's a series circuit. We talked about this with circuits in general, but just to clarify and to bring this up, an open circuit is when any part of the circuit is disconnected. So just so that we're real clear and bring this up definition-wise, so open circuit is when any part's disconnected. So like in that last example, if I pull out that light bulb, open circuit, disconnected. Okay, now more complex circuits. We have a parallel circuit. Parallel circuits are more complex. This is how most houses are set up. Like the room is set up in a parallel circuit. It's where you contain two or more branches for a current to move through. So notice if I look at the diagram here, you got your battery. It's going through, like you've got one here, and then you've got another branch here. In fact, this is kind of almost, if you go in our classroom, this is almost how it's set up. Like I've got one light switch that'll hold up these first set of lights in the front, and then I've got a second light switch that'll go the ones in the back. And so I can flip and I can make the front lights come on, but I can leave the back lights off, or I can turn both of them on, or I can turn both of them off. It's, the current can flow through both or either of the branches. They don't all have to be on at the same time. So there's lots of advantages to parallel circuits. You can turn lights on, you can turn lights off, you can have all of them on, all of them off. Think about your houses. It's a real advantage because it'd be like turning on your bathroom light, and if it wasn't set up parallel, turn on your bathroom light and like all the house lights coming on if they were set up in series. And that'd be really annoying, especially if you get up before your parents or your parents get up before you, because you don't want to wake them up by turning all the house lights on. And obviously we set up our houses set up in parallel so we can allow for individual appliances, individual fixtures, and so our houses are set up with a combination of parallel circuits, very organized, lots of networking in order to ensure that we can have these combinations of, you can be in one room and turn another room off and that kind of thing. Now, the interesting thing about the house is that the houses use main switches or circuit breakers or fuse boxes, and we'll talk about the difference between a circuit breaker and a fuse box here in a little bit. And so from the fuse box, which is the hub of the entire house, of course it branches out and it allows for, of course, as we already talked about, all these different areas to be used, and you can turn off at different points. within the house itself. Of course, that's why we have professional electricians who do these kinds of things that are very knowledgeable about what they do. And then, of course, you want to find the right person to do these kinds of things that know what they're doing. I have personal experience with a friend of ours who had an electrician wire their house and unfortunately did it incorrectly and their house burnt down. So you definitely don't want to find someone who doesn't know what, that you want to find someone who knows what they're doing, because, just because they don't wire this one little outlet right could take down their whole house. Okay, I said I'd talk about fuses versus circuit breakers. Fuses are kind of interesting. Fuses, you don't see them as commonly in most houses. Fuses are kind of an older thing. Fuses are these little things that they're a small little piece of metal that actually melts when the current becomes too high. And so it basically, what happens is you have this little piece that when it melts, it causes the circuit to become open. And so basically it breaks the circuit. So you have this little metal piece, it becomes too hot, it melts, the circuit overloads, it melts, and so you basically have to go and replace the blown fuse with a new one. So you take it out, you put a new one in, and it basically closes the circuit again, and so you can get it going. Sometimes it's too hot to replace the circuit, and you kind of have to wait a while. It just depends on the situation, but it's just a little piece that you can replace. And so that's kind of the idea with fuses. Now, you also have more commonly, and this is what our houses have, even the lab tables almost have their own little personal circuit breakers on them now. It just basically is a piece of metal. What a circuit breaker is a piece of metal that bends when the current is so large and it gets hot. So basically what happens is these little switches here, what happens is they're a little piece of metal inside, and then if it gets too hot, it just bends, and so the switch flips up to the off position. And then so it basically opens the circuit, meaning breaks the circuit, so you can't have any more electricity flowing. And so then, you basically then have to go and try to flip it back on. And then if it doesn't turn back on, sometimes you have to wait until it cools down, or sometimes you even have to, if it's bad enough, you have to replace this whole breaker. It just depends on the situation. Most of the time you could just flip it back on if it's just been overloaded. But the difference is that circuit breakers shouldn't have to be replaced. You should just be able to flip this back and forth onto the on-off position, whereas a fuse you have to replace. It's melting the internal position. This is just a bending, flipping the position.